The universe presents humanity with a fascinating challenge. Every time we build a more powerful telescope and look farther into space, we expect to uncover new answers. Yet the deeper we explore, the more we discover that some mysteries may never be fully resolved. For centuries, people imagined that scientific progress would eventually provide a complete map of the cosmos. Every galaxy would be catalogued. Every process would be understood. Every question would have an answer. Modern astronomy suggests reality may be far more complicated. The observable universe is enormous, stretching across distances so vast that ordinary numbers lose meaning. Light travels at incredible speed, yet even light requires billions of years to cross the largest cosmic expanses. When astronomers observe distant galaxies, they are not seeing those galaxies as they exist today. They are seeing ancient snapshots from the distant past. The light reaching our telescopes began its journey long before modern civilization existed. In many cases, that light started traveling before Earth itself had fully formed. This creates a remarkable situation. Looking deeper into space is also looking further back in time. Every powerful observatory functions like a time machine, collecting messages sent across cosmic history. Yet these messages become increasingly difficult to interpret. As scientists study the most distant regions ever observed, they encounter an intriguing puzzle. Some areas appear to contain less detectable light than expected. The difference is not dramatic enough to suggest entire galaxies have vanished. Instead, the challenge involves understanding how light behaves while traveling through an expanding universe. To understand this mystery, we must first understand one of the greatest discoveries in astronomy. The universe is expanding. This realization transformed science during the 20th century. Before then, many researchers assumed the cosmos was largely static and unchanging. Observations eventually revealed something extraordinary. Galaxies were moving apart. More accurately, space itself was expanding. Imagine drawing dots on the surface of a balloon. As the balloon inflates, every dot moves farther from the others even though none of them are traveling across the surface on their own. Something similar occurs throughout the universe. The fabric of space stretches over time, increasing the distances between galaxies. As light travels through this expanding environment, its wavelength also stretches. Visible light gradually shifts toward redder wavelengths and eventually into infrared radiation. The farther light travels, the greater this effect becomes. For many years, astronomers believed gravity would slow the expansion of the universe. But observations of distant stellar explosions revealed an astonishing surprise. Expansion is accelerating. Instead of slowing down, the cosmos appears to be growing apart more rapidly over time. Scientists attribute this effect to a mysterious phenomenon known as dark energy. Although its nature remains unknown, dark energy appears to dominate the large-scale behavior of the universe. Its influence introduces a profound consequence. Not every region of the cosmos will remain observable forever. There exists a limit beyond which information can no longer reach us. Light may continue traveling through space indefinitely, but expanding distances can prevent future signals from ever arriving at our location. This idea challenges our intuition. We often assume that if something exists, it can eventually be observed with sufficiently advanced technology. Cosmology suggests otherwise. Some regions may remain forever beyond our ability to access, not because our instruments are inadequate, but because the structure of the universe itself imposes limits. In this sense, observation becomes a race against time. Every photon arriving from deep space represents information successfully crossing billions of years of cosmic expansion. Each one carries a story from a distant era. And every observation reminds us that the visible universe is not necessarily the entire universe. It is simply the portion whose light has managed to reach us. That realization changes the way we think about exploration. The goal is no longer merely to see farther. It is to understand the boundaries of what can ever be seen at all. The concept of a changing observable universe leads to one of the most fascinating ideas in modern cosmology. Visibility itself may be temporary. Imagine standing on a shoreline and watching ships disappear beyond the horizon. The ships do not cease to exist. They simply move beyond the range where they can be seen. On cosmic scales, something similar may be happening throughout the universe. Galaxies continue evolving. Stars continue forming. Black holes continue growing. Yet expanding space gradually increases the separation between distant regions. Eventually, some locations become so remote that new information from them can no longer reach us. The objects remain real. Only our connection to them is lost. This phenomenon creates what scientists often describe as a cosmic horizon. Beyond that boundary, events continue unfolding normally. Civilizations could rise and fall. Stars could ignite and die. Entire galaxies could transform dramatically. Yet none of those future events would ever become observable from our position in space. Reality continues. Observation does not. This distinction may seem subtle, but its implications are enormous. It means that existence and visibility are not the same thing. Something can be completely real while remaining permanently inaccessible. As astronomers examine increasingly distant regions, they become aware that every observation captures only a limited fraction of a much larger reality. The universe is not a finished map waiting to be explored. It is a constantly changing landscape where the observable boundary evolves over time. Every year, new photons arrive after journeys lasting billions of years. Some of these photons provide the first glimpse humanity has ever received from particular regions of the cosmos. Others represent the final information we may ever obtain from certain distant sources. This gives modern astronomy a unique importance. Researchers are not simply gathering data. They are preserving information that may become increasingly difficult to obtain in the future. Humanity happens to exist during a remarkable era of cosmic history. The night sky still contains evidence from across vast distances. We can detect ancient background radiation left over from the early universe. We can observe galaxies billions of light-years away. We can reconstruct events that occurred long before our planet existed. Future observers may not be so fortunate. If intelligent civilizations exist trillions of years from now, their skies could appear dramatically different. Many distant galaxies may lie beyond observable reach. The evidence available to modern astronomers could be unavailable to them. They might struggle to determine how large the universe truly is because much of the information we possess today would no longer be accessible. That possibility transforms astronomy into something more than exploration. It becomes preservation. Every observation records a piece of cosmic history before it fades beyond reach. Every telescope acts as a bridge connecting the present to an increasingly distant past. And every discovery reminds us that knowledge itself can be limited by the architecture of reality. Perhaps that is the most extraordinary lesson modern cosmology offers. The universe is not hiding its secrets deliberately. There is no cosmic barrier designed to keep observers away. Instead, space, time, and expansion naturally determine what information can be shared across the cosmos. Some light reaches us. Some never will. Some stories arrive after traveling for billions of years. Others remain forever beyond the horizon. The universe continues expanding, growing larger with every passing moment. Yet as it grows larger, parts of it become less accessible. Distance creates separation. Time creates boundaries. And the observable cosmos becomes only one chapter of a reality far greater than anything we can fully witness. Somewhere beyond the edge of our observational reach, stars continue shining, galaxies continue evolving, and light continues its endless journey through space. Whether that light ever reaches us is another question entirely. And perhaps that is one of the deepest mysteries of all, not what exists beyond the horizon, but how much of reality can ever truly be known.